Welcome everyone, my name is Sammy and I'm here today to show you Lewis structure problems. Today I will be trying to focus on the ones that does not obey the octet rule, but I'm gonna start with one that actually does. So let's get to it, and I'll show you this one, H2O, water. This one's gonna actually obey the octet rule, but the next two was not gonna obey the octet rule. But let's get started. So H2O, water, let's begin with. First of all, the best thing you should do is calculate your valence electrons. See how many electrons you have. So we have two H's, and basically our periodic table, each H has one valence electrons. So that way we have two valence electrons for H, plus we have just one element of oxygen. We have one. So an oxygen has six valence electrons. So 6 plus 8, but 6 plus 2, that would give us 8 valence electrons. That's how it would look. So total electrons we have is 8 for the Lewis structure. Then we start beginning with our structure right here. So we know that oxygen is electronegative more than, of course, hydrogen. So we put it right here in the middle. Then we connect the two hydrogens around. Now, how many do we have? We all know, I'll put this right here. Single bond is 2 electrons. Double bond is 4. And triple bond is 6. So since we have 2 single bond right here so far, we know that we have, as we said, each one is 2. We have 4. We have 4, but we still need to get to 8. Therefore, we put the single dots right here. Therefore, we have 2, 4, 6, and 8. That's perfect right there. That's a complete Lewis structure form. Now, you may ask, why does hydrogen doesn't have 8 right here? Because hydrogen only needs 2 electrons to have a complete shell. It does not need more than 2. 2 is enough for it. That's all it needs. And as you see, it has 1, 2 for hydrogen right here. 1, 2 for this hydrogen. And then for this oxygen, 1, 2, 3, 4, 5, 6, 7, 8. 8. And this looks perfect right here. So you may ask again, another question too is, why did I do them like this instead of like a single line like that? That would be a good question, but that will get into bonding angles. I can tell you right now, as you see this single 2 dots, this is gonna bring a little bend to the structure. So physically, in the chemistry, when you put any single pairs, it's gonna bring some type of bend to the structure. So in this molecular geometry, we would call this a bent structure. We won't call it linear since it has lone pairs. But you will get that in your chemistry class later moving on. And it will be explained to you even a lot better. But it's just so you can have an idea, just so you can understand why I did what I did right here. Now, moving on, next structure is going to be xenon, fluorine 6. So we have 1 xenon and we have 6 fluorines. Again, like we did in the last problems, our first intention is to find out how many electrons we have. We know that xenon brings in 8 valence electrons, and we know that fluorine brings 7 valence electrons. Now we have 6 of fluorine. We have 6. We don't have so therefore we have to do 7 times 6 plus 8. 7 times 6, 42, plus 8, that would be 50. 50 valence electrons. That's how much we have in total. Now we get to doing the Lewis structure. Now we have xenon, and then we just start putting down the fluorines. Make one going that way, make one going this way, 3, 1, 2, 3, 4, 5, 6. Just gotta double check I got it right. Now, how many electrons we have so far? We have 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. I had to just double check real quick. That's how we get to it. So each of these fluorines still needs 6 electrons. So we just put our lone pairs right here. It needs 6 electrons to complete its shell. So we just keep on putting them. Now each of these fluorines has a complete shell now right now. They all have the octet rule. We have 6, 12, 18, 24, 30, 36. 36 electrons on the fluorines. 36, we'll keep right here. 38, 40, 42, 44, 46, 48. So we have 48 electrons in total right here. 48, and we know that we started off with 50. There we go. We cannot, this solar structure is not complete yet. We need to add those 2 electrons. So where do we add them? The best place for them, it will go right here on the central element, xenon. As you see, xenon has a lot of electrons right here. It's surrounded by a lot. And it breaks the octet rule by many. How many does it have? 2, 4, 6, 8, 10, 12, 14. This is breaking the octet rule, but that's okay because this is the only way that you can do the structure. And you will see those type of structures on your exam. Therefore, you have to be familiar with them when they come, and you have to be ready. So take a good look at this structure and see if this is actually good with you, and try to practice it on your own too, because when you practice on your own, it will stick with you, and that what happened to me. I had a lot of practice, and that's how I got better at doing these structures. Now let's move on and do another problem that could help you be more prepared for the ones that break the octet rule, because they're not all easy. So we get this right here. H3 PO4. H3PO4. This is the compound that we have right now, and as you said, we do the same thing again. Calculate how many valence electrons we have. We have 3 plus 5 plus 6 of these times 4. All these together, we add them together, we're gonna get a total of 32. 32 electrons. Yep. All right, now we just get to doing that Lewis structure. Now we start with B, central atom. Now we're gonna put our O's. Put one right here, put one right here, put one right here, put one right here. There we go. Now we have to connect our hydrogens. But first, before I do that, I'm gonna try to fill out the valence electrons. So put 2 right here, 2 right here, 2 right here, 2 right here, just so I can kind of see how the structure is gonna be. Because this compound is not that easy, it's a little bit complicated. Therefore, you have to kind of like set up and kind of study how you see the structure is going to look before you start writing it. Now, as you see, I still have 3 hydrogens that I haven't placed. The best solution for them is, as you see, I have 2, 4, 6. I need still 1 more single bond to make this complete, or 2 more lone pairs. But if I do that, I'm going to go over the electrons. So therefore, I'm going to put a single bond to hydrogen right here, and a single bond to hydrogen right here, another single bond for hydrogen right here. Now this is good. Octet, octet, octet. Like I said, hydrogen earlier only needs 2. So octet, this is full, full, and full. Only problem is, this is not full. And I don't have any more hydrogens to put. or electrons. Or lone pairs, I'm sorry. So what do? Put another bond right here to have two double bond. So double bond, single bond, single bond, single bond. This is the only one that's gonna have a double. Since I don't have any more hydrogens. If it was H4, that could have probably fit in, but again, probably wouldn't work because the electron would differ and become 33 instead of 32. So let's count how many electrons we have. 2, 4, 6, 8, 10, 12, 14, 16, 18, 18, 20, 20, 22, 24, 26, 28, 30, 32. 32 electrons. Complete. Thank you so much for watching, and if you have any more questions, please comment below. Those structures, they take a lot of practice, but once you master them, they will become really easy. Thank you so much, and you all have a good one.